We're going to let C be an 8-bit number and consider the operation of C equaling C ANDed with DF. So we're asked, how does this operation affect C? Well, whenever we do an AND, it's going to be typically a change. So let's look at this. We're going to be clearing. So that's what we're focusing on here. So when we're dealing with hexadecimal, which is what this is, C is a hexadecimal. If we have a 0x, we know it's a hexadecimal. So with hexadecimals, we know that A is equal to 10, B is 11, C is 12, D is 13, E is 14, and F is 15. And since this is 8 bits, well, it's 4 bits by 4 bits, so it's going to be 2 cubed, 2 squared, 2 1, 2 0. So now let's solve for C. Solving for C, if it's 12, that means we are going to have 2 to the power of 3, which is going to give us an 8. So we have 1 here, and then we have 2 to the power of 2, it's going to give us a 4. 8 plus 4 is 12, so we have 1, 1, 0, 0. Now we can write this out. For C, all we have is this 1, 1, 0, 0. And this is going to be A to the 0, or C to the 0, C to the 1, C to the 2, C to the 3. So we're going to have C to the 4, C to the 5, C to the 6, and then C to the 7 right here. Next, we have our DF. And so for our DF, we'll do it all in one line, just like this. So our D is going to be 13. Very similar to our C, we're just adding 1. So it's going to be 1, 1, 0, 1. And then our F is just going to be 15. It's going to be all of these, so we just have 1, 2, 3, 4 ones. So let's plug this in here. So we're going to have a 1, 1, 0, 1, 1, 1, 1, 1. Now, notice how that's being ANDed together. When we have AND, we're going to be clearing. So, with this, we see that nothing is happening here, because this 0, 0 is going to stay the same since they're ANDing together. So that's not going to affect our C. These are both 1, 1s, so it's going to still be a 1, 1. Basically, when we AND all of this parts together, C is not going to change. Now, let's keep going. If these are 1s, these right here, notice how these are also 1s. So if they are ANDed together, it's going to give us 1s. Now, if our C's are 0, it's going to give us 0s. So this is not going to change our C7, C6, and our C5. Nothing's going to change here. Well, or C4. What about our C5? Well, C5, we see we have a 0 here. And this is important because if our C5 is a 0, sure, that's going to be a 0 right here. But what if C5 is a 1? Well, that's still going to be a 0 from this 0. And so that means we are going to be clearing our bit 5 of C. So when it says let C be an 8-bit number and consider the operation C is equal to C ANDed with our DF, how does this operation affect C? Well, this operation is going to be clearing the bit 5 of C. And that's how you would solve for this problem, and anything like it.